presentation.
Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Your questions are great. Give us a call, 866-323-2538. I know some people are kind of hesitant because they say, well, my question's kind of dumb. You'll probably laugh. But realize that sometimes the simplest questions are the deepest questions of all. What is life? What is light? I mean, these are the questions that Charles Darwin and Albert Einstein, and look, they changed world history as a consequence of their theories, starting from simple questions like, what is light? And so that's why we want you to call 866-323-2538. Okay, moving right along. Let's take the next listener phone call.
Hi, my name is Kenneth Eng. I'm listening to you on AM 1600 here in New York City. My question is, why is the unification of quantum mechanics and relativity considered to be the theory of everything? From my understanding, quantum mechanics and relativity are only proven by experiment. Isn't it possible that there are other universes in which quantum mechanics and relativity do not apply? For instance, light can travel faster than the normal speed. People can travel faster than light, which would invalidate relativity. So, wouldn't it be such that the unification of quantum mechanics and relativity only qualifies as the theory of everything in our universe, not other universes?
Well, Ken, you actually ask a question which is the center of a lot of debate now in scientific conferences. One of the central questions in cosmology today is, are there other universes? Einstein says that the universe is like a bubble. The bubble is expanding, and that's called the Big Bang Theory. And that's governed by relativity, the theory of the very big, okay? But then the question is, what about quantum mechanics? Quantum mechanics is the theory of the very small. And if I have an electron can exist in multiple states. That's why we have laser beams. That's why you can listen to my voice. Electronics, radio, television, they're bizarre things if you think about it. They violate common sense. Who would have thought you can have something like television? But why is it possible? It's possible because electrons could be more than one place at the same time. So if electrons can be more places than one at the same time, and you combine the quantum theory with relativity, the theory of this gigantic bubble universe, then you now have the astounding conclusion that the universe may also exist in multiple states. And that's called the multiverse. And so the multiverse idea is taken very seriously now. And the only theory which could theory of the big, relativity, with the theory of the small, the quantum theory, is string theory, and that's what I do for a living. And string theory seems to vindicate this picture. String theory has many solutions. Each solution is an entire universe. And it turns out that in some of these universes, quarks can be unstable, protons can be unstable, in which case matter simply dissolves and forms a mist, a gas. So in some of these universes, they do not obey the normal laws of quantum mechanics and relativity, just like you pointed out. Our universe does. But when you solve string theory, you find that it has other solutions that look just like ours, except there's a twist. So in some universes, perhaps Hitler was never born. Perhaps a cosmic ray went through Hitler's mother. She had a spontaneous abortion, a miscarriage, and Hitler was never born, and 60 million people didn't have to die. Well, yeah, this sounds like science fiction, but this is something that we physicists take very seriously now, because this is where string theory is taking us. So to answer your question, yes, there could be other universes with different laws. Atoms are not stable, or different forms of atoms can exist other than the atoms that we're familiar with. However, you may say to yourself, how do you prove any of this? We'll prove this theory by using machines like the Large Hadron Collider. The Large Hadron Collider has bagged the Higgs boson. The next thing to be discovered is dark matter, particles or superparticles predicted by string theory. And once we find particles and dark matter with the Large Hadron Collider, that could go a long ways towards vindicating a theory of everything. A theory of the very small combined with a theory